Good morning to all.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Hmm. 23 people implies out of that 2 people removed me, host, and co-host. 21. Only 21 people did the assignment. That's good. Fine. This is the assignment sheet, right?
Yes, sir.
Yes, sir.
Equivalent resistors and capacitors. Tell me your doubts.
So 12th. So 20th.
20.
Yes, sir.
Sure, 8,
19. 19.
18, 26 second, 24th, 6th and 8th,
Fine. Sincerely tell me, you people have attempted the assignment, right?
yes sir,
So not fully.
Yes, sir.
कहाँ तक नॉट फुल्ली मींस कल क्लास में ना चला था यार, बोल क्लियरली बोला हुआ है डिस्कस करूंगा प्लीज स्पेंड टुनाइट.
So
कहाँ तक अटेम्प्ट किया है?
23 तक पूरा हो गया. 24, 25, 26 बाकी है.
अजीब लोग है यार. तो क्या करूं मैं?
सर करो, डिस्कस चलेगा.
8th प्रॉब्लम. 5 वोल्ट बैटरी, वन ओम, 10 ohms, 2 ohms, right? 2-volt battery, done. Current in the 10 ohm resistor. There are three possible ways of solving this problem. Right now, you know one, which is KVL, Kirchhoff's law. I start with current I here, small I here, capital I minus small I. In current electricity, I teach you the other two. I go, this is small I, this is capital I minus small I. I will get back I into this branch. Capital I minus small I enters, capital I minus small I comes. Clockwise direction and touching the negative plate first. How much is this? 5 volts, right?
5 volt, yes, sir.
In the direction of current, minus 2I plus 5 minus 10I is 0. Here I am going anti-clockwise direction. Opposite to the direction of current, I minus I into 1 minus 2 minus 10I is 0. Eliminate capital I, you get small I. Eliminate capital I, you get small. Twelfth is a tricky question. Tell me when I can rub the book.
Yes, sir.
12th, have patience. Let me draw the diagram first. This drawing the diagram also will take some time. All resistances is of resistance R. You want the equivalent resistance across AB. ध्यान से देखो. Haven't we short circuited this resistance? You have connected this end and this end. There is no resistance in between. So you have short circuited this and this. First point. Do you agree with that?
Yes, sir.
Similarly, have you short circuited this? You have connected this end and this end. Have you short circuited this?
Yes.
Yes, sir.
Can I claim these resistances are in parallel? Have a look at it. This point are equipotential.
Yes, sir.
All I will do is just make a change in this resistance. I bring this point here, which I'm completely eligible of. Right? Similarly, bring this point here. Can I do the same thing with these both resistors?
Yes, sir.
Now I believe you don't have a further problem with this. These four are in parallel. These four are not in parallel. First, R and R are in series. This R and R are in series. That is in parallel. This R and R, I'll make them 2R here. Do you agree with that? Similarly, make this 2R here. Now these four are in parallel. These four are in parallel. That is in these two are in series. From here, it will not be difficult. All you have to recognize is 4 resistors are short circuit. But
So can we do this by symmetry also?
you series pair. See, listen the sequence. First series pair. That's the simplest. जब आपको series parallel आ जा रहा है, don't go for higher levels. Right? You can solve using symmetry, but I would not suggest. Go in the sequence. See, in the examination hall, you will not have time to think in multiple directions. So format your mind in such a way so that you follow the sequence and immediately strike out the problem.
Okay, sir.
Series parallel, then search for Wheatstone bridge, then go for symmetry, and then use KVL and others.
Yes, sir.
Everyone can get the board. Next you said was 18. Agreed. This is also one tricky problem. This is 3 ohms. This is 4 ohms. This is A, this is B, and this is a 25 volts battery. Find the current flowing to the segment AB of the circuit shown in the figure. Right? Technically, this is 0 volts, this is 25 volts. This is 0 volts. I'll call this V0, this will also be V. Right? So what is the current in this branch? 25 minus V0 by 1. Take the current in this branch as I. The current in this branch is V0 minus 0 by 2. Total incoming current should be equal to the total outgoing current. Here it will be 25 minus V0 by 1 should be equal to I plus V0 minus 0 by 2. This is my first equation. I have two variables V and I.
Yes.
V0 and I. I have two variables, right? Now do the same thing here. Here I have current how much? 25 minus V0 by 3. Incoming current is I. Should be equal to the outgoing current. V0 minus 0 by 4. Incoming current is equal to the outgoing current. Incoming current is equal to the outgoing current. This is incoming. Now from these two equations, you have two variables, V0 and I. Eliminate V0, you get I. वही तो पूछा है उसने.
Sir, why will any current flow through the AB branch because the potential difference is 0 there?
Listen carefully. V equal to IR. Potential difference is 0. Either when current is 0 or resistance is 0. You are telling me one condition. Right? Resistance is 0 here. So potential difference is 0. Current need not be 0. In 90% of the cases, this will be the situation ironically. V will be 0 when resistance is 0. Need not be that current alone should be 0. Second, in that case, in the question that you asked, are these 2 points equipotential or not?
Yes, sir.
There is no resistance, hence they are equipotential. Then do you tell me there is no current in that wire?
No, sir.
So potential difference is 0 does not always mean current must be 0. It can as well be resistance is 0.
Yes, sir. Thank you.
So for this, I used a different method. Like I found the current in all the four resistance. Like
Subtract, I have no problem. This current, this current, this current, this current, total current coming should be equal to total current going. Balance is this current. I have no problem.
Done, sir. Sir, I don't have a doubt in 19.
Somebody else having 19th doubt? Twentieth, in the given circuit, if the potential difference across R is 100, then find the value of R. Have a look at this. This is 120 volts. This is 10 ohms, 100 ohms. This is R. Delta V is equal to 100 volts. Now consider this situation. Potential difference across this and potential difference across this will be the same.
yes, sir.
Potential difference across this and across this will be the same. Right? Suppose I don't want to use nodal analysis, I don't want to use anything. See, actually, if you take 0 volts, this will be 120 volts, this will be V naught, right? This will be 0 volts, V, right? So how much is V naught? You already gave me potential difference across this is 100. So V naught will be 100. V naught is 100,
Yes, sir.
right? Now, you know the current in this now. How do you know the current in this? I into 100 is equal to 100. That means I is 1 ampere. The
Yes,
current coming in this is 1 ampere. What is the current coming in this branch? 120 minus 100 by 10.
sir.
120 minus 100 by 10. This is 20 by 10. This is 2 amperes. 1 ampere is going in. How much is going here? 1 ampere. What will be the value of R? 1 into R is 100. R should be 100 ohms. I don't want to follow this procedure here. Apply KVL. Capital I, small I. Two loops, two equations. Third equation is small I into R is 100. Capital I, small I. Take it down till here and solve using KVL also, so that you will get accustomed to it.
Done, sir.
Suppose I don't want to apply nodal analysis. I'm okay with it. Use capital I here, small I. This will be capital I minus small I. Apply KVL to this loop, apply KVL to this loop. You'll have two equations. Yes or no? You're touching here 120 minus 10I minus 100 I minus I is 0. Opposite to the direction of current R into I minus I into 100 is 0. I have two equations and two variables, but R is also a variable. For which he gave a third equation. I into R कितना बोला उसने? सो रेज of किस?
100.
Into R how much?
100.
100. Now you have two equations, two variables. Will I calculate small I? Once I get small I, will I be able to calculate R?
Yes, sir. Done, sir.
$22. You people said 9. Am I right? In fact, yesterday only we dealt with this, but for practice I'll do it again. 4 and 10. You want the equivalent resistance across AB. You want the equivalent resistance across AB. Now watch out for this. This is not a weak stone bit. 4 by 10. 8 by 10 is 4 by 5. This is 1 by. Right? One procedure is star delta transformation. The other is KVL. Which one do you want me to use?
KVL.
KVL. I take this to be 100 volts. You can take anything. Capital I take it as small I. This will be capital I minus small. Now I take this as I naught. This will be I minus I naught. This will be capital I minus small I. KVL, I'll have three equations. Nodal analysis, I will have two equations.
But shouldn't it be capital I minus I naught 10 ohm के आप में?
Capital I minus I plus of I minus I naught. Capital I minus I. Right? Okay, I'll solve using KVL now that we have come till here. Nodal analysis, I'll have only the potentials of these two. Right? But I'll show you nodal analysis also. Don't worry about it. First of all, this capital I minus small I plus this small I will get cancelled out with this. Now apply KVL to this. 4I minus I minus 2I, 2I minus I naught is equal to 0. Opposite to the direction of current, minus 10I minus I naught plus 8I naught minus of 2I minus I naught is 0. 100 minus 4i minus I minus 10i minus I naught is 0. How many variables do you have? I naught, capital I, right? I naught, I. What is your requirement? You have three equations because you have taken this as some 100 volts. If not, this would be a variable. We don't mind. My requirement is V by I. Eliminate I and I naught from these three equations. I'll get V by I, 100 by capital I. So here, my requirement is 100 by capital I. That means from these three equations, I should calculate capital I. I need to eliminate I and I. Will you be able to do? Say something.
Yes, so
I'll do even using nodal analysis. It will be one equation lesser. Two equations here will make your life a bit simpler.
Done, sir.
Now suppose I solve this using nodal analysis. What you do here is, this is call this potential as X, call this potential as Y. This will be 0 volt, this will be 100 volts. This is 100 volts. Right? Now watch out for this. Ultimately, you need this I. R equivalent is 100 divided by I. I will be what? I will be 100 minus X by 2 plus 100 minus Y by 4. This is I, which I'll have to substitute here. I get my answer. Yes or no? Capital I is 100 minus X, 100. Capital I will split into both these branches. Say something, yes or
yes,
no?
sir.
Yes, sir.
Yes, sir.
Today we have covered this in the class, but nodal I applied for capacitors. So I'm intentionally doing it even for resistors so that you people know how to do it. It is 100 divided by total incoming current is R equivalent. So this I splits into this branch and this branch. What is the current in this branch? 100 minus X by 2, 100 minus Y by 2. Now I need to calculate only X and Y. The only two variables. So I need only two equations. Simplification will be simpler. Do you agree with that?
Yes, sir.
So when here I don't have the same resistances here and here. In the example I have taken in yesterday's class, I took the same resistances here and same resistances here. So I knew that the current here and here are the same. But here the resistances are different. So a new variable comes in. So there will be three equations and three variables. If I use Kirchhoff's, nodal will have only two equations. Please have a look at it. Now this incoming current should be equal to the outgoing current. What is the incoming current? 100 minus x by 2. Outgoing current x minus y by 2 plus of x minus 0 by 8. This is 0. Now this incoming current should be equal to the outgoing current. 100 minus y by 4 plus x minus y by 2 should be equal to y minus 0 by 10. This incoming current summation should be equal to the outgoing. Now, one mistake you're not supposed to commit. In the first equation, you took current going from x to y. Second equation, you cannot take current going from y to x. You have made the choice in the start, stick to it.
Yes, sir. Done, sir.
Twenty-third. 23rd, did I write this correct? 7th bit. Am I right? This wire connected here is as good as this. This was the connection that he has given, right? बड़ा आसान क्वेश्चन है, डिसेप्टिव है बस. See, this point is as good as connected here. It's just confusing the students. This point is as good as. These both points are at the same potential, right? Yes or no?
Yes, sir.
No. These both are in parallel. These both are in parallel. That is in series. Parallel means 2 and 2 is 1. 1 ohm. 1 ohm. Right? 2 ohms. 2 and 2 is 1 ohm. 2 and 2 is 1 ohm. This is 2 ohm. Now these both are in series. That is in parallel with this. Problem is very easy but deceptive looking problem. At the first instance, it will appear very confusing. That is the case with even 23rd second question. 23rd second question. When you look at the problem, it appears weird, but it's a very easy problem.
Done, sir.
Twenty-third, ninth bit. 23rd, did they say 9?
Sir, it was 11th.
11.
11. 2 ohms, 15 ohms, 10 ohms, 10 ohms, 8 ohms, 20 ohms, 30 ohms, 40 ohms. But the first instance, 15 and 10 are in series. Do you agree with that?
Yes, sir.
Yes, sir.
Can I make this 25 ohms?
Yes, sir.
40 and 10 are in series. Can I make it 50 ohms?
Yes, sir.
Right? Now, I can take this point here and this point here. Now, when I do that, 2 ohms. Have a look at this. This junction is nothing but this point. This point should be placed here. This point should be placed. These both are in series now. Do you agree with that?
Yes,
This
sir.
is
Yes,
8
sir.
ohms. 20 and 30 are 50 ohms. Now I'm bringing this point here. This point here. This is 50 ohms, right? This resistance will come parallel to these both
Yes, sir.
50 and 50. Now connect this point here. When you are connecting this point here, okay, just a minute. I missed something here. One second. This is 8 ohms. This is 50. That's 25, 50. Right. I'll redraw the circuit like this. Yeah, just a minute. This is 2 ohms. This is 25. This is 50. Eight ohms. This is 50. This is 50. This goes till here. 2 ohms ending. Did I copy the diagram properly? After 2 ohms, you have connected it to this. Right? This I have connected to this. Is the diagram correct now?
Yes, sir.
Catch hold of this and stretch it out. You get the answer in one step. Where did I keep this paper? Now I'll put it this way. Have a look. Or you want to keep it here. This is 2 ohms. Right? This is 8 ohms. These three will come down to be in parallel. 25, 50, and 50, they'll come here. This is 25. This is 50. Rearrange them using numbers you get. See, 25, this end, you're placing it here. That means the 25 will come parallel to both of them. Do you agree with that when you place this here?
Yes, sir.
25, when you placed it here, just imagine, I'm moving that 25 from this and I'm placing it here, and the 50 also I'm placing it there. 50 also I'm placing it here. Right? When I removed that point and placed it here, 25 and 50 came this way. Do you agree with this? The 50 comes over here because this end of 50 is connected. Now go ahead connecting these 2 points, 25, 50, 50 are in parallel because this 50 and this 50 are in parallel.
Yes, sir. Done, sir.
How many of you have not done after 23? Please raise your hands. 23 के बाद जो problems नहीं हुए, please raise your hands. Raise your hands. I'll give you people time to solve. Very important. I shouldn't discuss it without you people at all. Twenty-three or 24? You people have attempted up to 23 or 24?
सर लास्ट टाइम आपने 23 तक दिया था.
वही
Yesterday आप
किया,
24
कल रात आपने
23.
नहीं किया है. बहुत गुस्सा आ रहा है यार.
Sir, I did it.
सुनो, 24 and 25 makes no big deal, but 26 is very important. You cannot skip the 26. You have to attempt only, then I should discuss. So I'll keep that pending. Next class, remind me. I'll first finish this and then we will go ahead. Is that clear?
Yes, sir.
And there the main part here. 23rd, somebody is asking 12th bit as well. 12th bit is series parallel here. 23rd, 12th bit, 5 ohms, 3 ohms, 8 ohms, 2 ohms, 9 ohms. This is a sorry, 2 ohms, 2 ohms, 6 ohms, 35 ohms. Is this the complete question?
Yes, sir.
Now listen. 2 and 2 are in
Parallel.
2 and 2 are in parallel. Is everybody able to see that?
Yes, sir.
They are resistances or capacitors. I misplaced the question. Did I draw the diagram correct? They are resistances or capacitors?
So resistors.
Mm.
Okay. Two and two in parallel, equivalent resistance will be 1 ohm. 6 and 3 are in parallel. Do you agree with that?
Yes, sir.
Equivalent resistance will be
2
2
ohms.
ohm. Or 6 and 3, I'll put it this way. 6 and 3, 2 ohms here, right? One and 9 are in series. Do you agree with that?
10.
Yes, sir.
And 5 and 2 are in series. Do you agree with that?
Yes, sir.
कुछ दिख रहा है?
Sir, 8 is the Wheatstone bridge.
Resistor bridge.
Can I rub the board?
Yes, sir.
Will you solve one problem?
Yes, sir.
Yes, sir.
One ohm, 10 ohms, 10 ohms, 10 microfarad, 10 ohms, 10 ohms, 10 ohms, 5 microfarad, 5 ohms, 10 ohms, 10 ohms, 10 ohms, 10 ohm and 10 ohm. This is connected to a 100-volt battery. In steady state, find the charge on the 10 ohm resistor. In steady state, find the charge on the 10 ohm resistor. Implies what have you to find out? You should find out the potential difference across this. Do you agree with that?
Yes, sir.
Yes, sir.
To get the potential difference, I should get the current in this branch. You give me the current, I tell you the energy or charge on this capacitor. Give me this current. And in steady state, don't forget this word in steady state. In steady state, find charge on 10 microfarad capacitor. Will you try or should I discuss?
I will try.
I am waiting.
Sir, is it 750 microcoulomb?
I
Yes, sir.
think
I
750 नहीं, current कितना आ रहा है?
sir,
From
7.5.
7.
Sir, current in that 10 ohm wala is 7.5 by 2.
Is it? Oh, I gave 5 here, right? हो सकता है, हो सकता है. Listen, in steady state, there will be no current in this branch. It will be completely charged. So temporarily I'll remove it because I need to calculate current in this branch. Do you all agree with that? Same applies
Yes.
to this capacitor. Now 10 and 10 are in series. Can I write this as 20 ohms? Similarly, 10 and 10 are in series. Sorry, 20.
Yes. Sir.
20, sir.
Now 10 and 10 are in series. 20 and 10 are in parallel. How much will the equivalent resistance
20
be?
by
20 by
By
3. 20 by 3.
20 by 3. This will also be 20 by 3. Are you able to see the unbalanced Wheatstone bridge? Here, don't apply star delta because he didn't ask you for equivalent R. He asked you for the current in this branch. If this is capital I, this is capital I minus small I. Capital I minus small I and small I. This will be this minus 2I minus capital I. Apply KVL to this loop. 20 by 3 into I minus I minus 20I minus 5 into 2I minus I is 0. Minus 20I plus 20 by 3 into I minus I minus 5 into 2I minus I is 0. Two equations, two variables, find small I. Once I get small I, potential difference is equal to 20 into small I. Q will be equal to C into the potential difference, CV. Somebody is asking, can you repeat the capacitor part? Capacitor part का क्या मतलब?
Sir, initially आपने capacitor क्यों निकाला था?
Steady state, there will be no current in it. All that you need is the potential difference across the capacitor. Q is equal to C. To get the potential difference, I should get the current in this branch.
Okay, sir. Got it.
Tell me when I can rub the board.
Yes, sir.
In the initial stages, I must have done one problem where you have a resistor here, capacitor here, resistor here. Before we learned, just when we learned KVL, charge on this capacitor. Have I done this?
Yes.
Potential difference across this whole of that will appear across the capacitor as the
That's a dummy.
in this branch.
Yes.
Yes, sir.
Sir,
This problem was based on one more tricky problem. Please solve this. This is 4 ohms. This is 5 ohms. This is R. This is X. This is 20 ohms, 8 ohms. A and B. The question says equivalent resistance across AB should be independent of R. Find X. Equivalent resistance across AB is independent of R. Find X.
So is it 20 ohm?
1 second. Let me see the answer. Return the 26. 2, 11, 20 ohms is correct. Listen, simple logic. If it should be independent of R, it should be a Wheatstone bridge. I'll just rearrange the circuit. Have a look at it. I will bring 5 here and I will bring the terminal A here. Deceptive loops are being removed. Right? Now, these both are in parallel. 20 into x divided by 20 plus x. Where will I place this? I'll remove this. I'll bring b here and I'll place this here. 20 into x divided by 20 plus x. Do you agree with that? When I bring b here, the resistor will come here. Can you bring it that way? I can bring it this way. Now the problem becomes very easy for all. Isn't it? When this by this is equal to this by this, it is independent of R.
Yes, sir.
Say something.
Yes, sir.
Can I rub the board?
Yes, sir.
Yes.
There is one small thing about infinite series. Infinite series has got nothing to do with physics. It is playing with numbers. It is playing with numbers. What do you mean by infinite series? Infinite series. You mean to say any number of building blocks you add up does not affect your answer. Infinite series means any number of building blocks you add doesn't affect your answer. And when will that happen? Have a look at it. Recognize the building blocks. After every building block, I should get the same answer. 2 ohms, 2 ohms, 2 ohms, 1 ohm, 1 ohm, 1. You're telling me any number of building blocks I have, my final answer is the same. Why will it be the same? Because the answer keeps repeating after every building block. The answer keeps repeating after every building block. You stop here, whatever answer you get, you stop here, you get the same answer, you stop here, you get the same answer, you stop here, you get the same answer. Is the other way of telling you that the length of the ladder doesn't affect your answer. When the length of the ladder doesn't affect your answer, that means wherever you stop after a building block, your answer will be the same. For example, have a look at it. You are telling me if I take R here, I will get here also R. This is what you are telling me. I get R here, I will get R here. After 100 blocks, I will get R. This is what it is a game of numbers. Number theory, nothing to do with physics. 2 and R are in parallel. 2R divided by 2 plus R plus 1 should be equal to R. 2R plus 2 plus R is 2R plus R. You are left with R square minus R minus 2 is 0. Could you tell me the roots of this quadratic equation?
2 and minus 1.
2 and minus 2 and
Minus 1.
minus 1 I'll eliminate. So 2 is my answer. Have a look. I stop here. I'll get 2. 2 and 2 are in parallel. Equivalent resistance is 1. 1 plus 1. Am I getting back 2?
Yes, sir.
2. 2 and 2 are in parallel. Equivalent resistance is 1. 1 and 1 are in series. Equivalent resistance is 2. 2. 2. Now any number of building blocks you put will have the same answer. Makes no difference for me.
Yes, sir.
This is all about infinite series. I'll just be back in a second. Can I rub the board?
Yes, sir.
Recognize the building blocks. That's the key catch. So on. I want the equivalent capacitance across AB. 1 microfarad, 2 microfarad, 2 microfarad, 2 microfarad, 1 microfarad, 1 microfarad. Find the equivalent capacitance across AB.
Uh, 2 microfarad.
Is correct. Here the building block is 2 and 1, 2 and 1, right? That implies I put C equivalent here, I will get same C equivalent here. This is 1 microfarad, 2 micro, right?
Yes, sir.
When the values keep increasing or decreasing, that I deal with in current electricity, right? Find the equivalent resistance across area. Find the equivalent resistance across area. Equivalent resistance across area.
Sir, 38/7 R.
अरे नहीं अच्छा नंबर है यार.
It was 7R/5.
What did you people do?
I folded the circuit.
Along
Yes.
this line you folded.
Yeah, along AB.
This point and this point are equipotential, so I can fold this point are equipotential, so I can fold. So this will become R by 2, this is removed. This will become R by 2, this is removed. This will become R by 2, this is removed. This is R by 2, this is removed. This is R by 2, this is. Problem becomes so easy after that. R by 2, and R are in series. This is 2R. R by 2, R by 2, R by 2. This is A and B. This is 2R. जो आंसर आएगा वही. These both are in parallel, that is in series with that.
Yes, sir. 7 R/5.
Okay.
Yes, sir.
This positive terminal is below this positive terminal at the left, this positive terminal to the right. This is 5 volts, positive terminal to the right, 15 ohms, 30 ohms, 5 volts, and find the current through the 30 ohm resistor and the 2 ohm resistor. Find the current in both the resistors. Find the current in both the resistors.
So, current across all the resistors, huh? Like
2 and 30.
two. Okay. That is 0.5 and 2.5.
I think, I don't know the answers, I'll solve.
Okay. So
Here,
nodal analysis only, no?
nodal will be much easier.
How much is it?
Somebody wants to solve using KVL, please have a look. You can take any possible direction. Take capital I, small I, capital I minus small I. Right? And here I will take I naught, capital I minus small I, capital I minus small I plus I naught. Come back as I. 1, 2, 3. 3 equations, 3 variables. Capital I, small I naught. Agreed? KVL procedure, did all of you understand?
Yes, sir.
I will not solve using KVL because more the number of batteries any time nodal analysis will be much easier. Batteries without resistance जब होंगे to use nodal analysis because you'll get the potential difference easy. Start from anywhere. Shall I start from here? I'll take this to be 0 volts. This will be 5 volts. This will be 5 volts. This will be 5 volts. This will be 10 volts. Now, if this is 0, this is 0, this is minus 5 volts. This is also minus 5 volts. Am I right? Direct इसका current आ गया 10 minus of minus 5 by 2 is the current in this branch. Now this is minus 5. How much will this be? Minus 50? No. 10. The current in this branch will be 10 minus of minus 15 by 30. As simple as. Current in this, you know if this is 5, this is 0. Am I right?
Yes, sir.
0. 0, 5. 0 minus of minus 5 divided by 15 is the current in this branch. Nodal will be much easier in this case. Whenever they give you batteries, that too without internal resistances, nothing better than nodal because resistor doesn't interfere with your problem at the first place.
Yes, done.
Now the next part that I have to deal with is one of the most important controversies in capacitors. The last solved example of HCV in capacitors is a conceptual blunder. Right? It will take us one complete 2 hours of a lecture, which I will not do it online, I will be doing it offline. Right? But homework you people need to complete. It is disappointing to see. If not, I would have discussed the last 2 questions as well. And you will have quite a few doubts in the 26th question. Main doubts I have to discuss is in the 26th question, which you people have not done. Now that's a tricky part there. Next class, when I'm dealing with this controversial problem of HCV, it will consume complete 2 hours of a lecture. वो एक क्वेश्चन हमें 2 घंटे लगेंगे. So then I will not be able to discuss it in that class. Then that day evening, whichever day I'm taking a class, I'll keep a half an hour of a doubt lecture and clear the doubts of this assignment. Today I would have done it if you people have done it. Hence I insisted yesterday's class. Please do it. Okay. We'll stop here. Next class we'll all be almost done with capacitors with that controversy done. Next class, please be present in the class. It is a very important class. You will not forget it all your life.
Yes.
Clear?
Sir, in the 26th question, I used star delta conversion in 2-3 questions. So is it okay?
Okay, but थोड़ा लंबा पड़ेगा because R is replaced with 1 by C.
Yes, sir.
So can you just like I forgot to ask the 11th one. Can you just do that quickly?
11 of
Of the equivalent resistance and all. 11th one.
10 and 4 are in, sorry, no,
We can't say 10 and 4 are in series, no?
no.
Because the three is in the middle.
This is the Wheatstone bridge wala question.
It's a Wheatstone bridge, right?
Yes, sir.
10 is the Wheatstone bridge.
Yeah. Rearrange them carefully this way. 11th one. This is 6 ohms. This will be 8 ohms. This will be 10 ohms. This will be 3 ohms. This will be 4 ohms. This will be 7 ohms. This will be. This 4 I can bring it here, right? This by this is equal to this by this. Remove this.
Okay.
So see you people in the next class. Good day. Bye.
Bye, sir.
Bye, sir.
Bye, sir.